So you write down. All right. So now, so we yesterday we did that, what is the unit of charge? The unit of charge is coulomb. Then we did what is an absolute charge, right?
Yeah.
And what is a relative charge?
Yes.
What is an absolute charge and what is a relative charge, right?
Yes.
And we understood that electrons and protons both have the same amount of charge.
Yes.
Electrons and protons both have the same amount of charge. But what is happening? What is happening? When electrons and protons they have the same amount of charge. So for electron we take -1, for protons we take +1. Also,
Yes.
you understand there is a term called as the quantization of charge. Write it down. There is a term called as the quantization of charge. Now, what do you understand by the quantization of charge? Just see. Quantization of charge basically means, that let's suppose we have a body A and we have another body B. And obviously, both the bodies are neutral,
Yes.
isn't it? Both the bodies are neutral.
Yes.
So, when both the bodies are neutral, what is happening? Understand? What is happening? There is a body A and there is a body B, and both the bodies are neutral.
Yes.
But let's suppose something happens, and it's something like this, that body A has to transfer charge to body B.
Mm-hmm.
A has to transfer body to body B.
B. Yeah.
So just tell me one thing. How would you think the charge would be transferred? The charge would be transferred in the form of electrons because only electrons are free. Because
Yes.
only electrons are free. I hope you're understanding. So
Yes.
when we are talking about the electrons, right?
Mm-hmm.
So these electrons are transferred from body A to body B. So let's suppose electron is one particle. Another electron is another particle. Another electron is another particle. So in one particular go, okay,
Mm-hmm.
the electrons are transferred. So from one body to another body, do you remember? Can you understand that one full electron shall be transferred, or two full electrons shall be transferred? Yes or no?
Yes.
What is the point? The point is, that it has never been possible that half electron would be transferred. It would never be
Yeah.
possible that half electron would be transferred. Are you
Yes.
understanding? What is
Yeah.
the point? The point is that this is called quantization. Quantization means the complete transfer, the complete transfer of whole number of electrons is called quantization. So when I say the charge has to be transferred, right? So I would say what charge is transferred. So I would say charge of one electron is full transferred. Charge of, let's suppose two full electrons are transferred. Charge of, let's suppose three full electrons is transferred. Charge of, let's suppose four full electrons is transferred. Are you understanding?
Yes.
That means what? Charge of n full electrons is transferred. So n here would be a whole number. N is not going to be some fractional number. I hope you're understanding,
Yes.
right? So what is the point? The point here is that when we are talking about the quantization of something, it means complete transfer, complete transfer in whole numbers of electrons. Yes or no?
Yes.
Always understand this concept. Next, what do we have in here? Next, we have, so this is a very important formula, Q equals to NE. All right.
Okay.
Okay, so let's suppose what kind of questions can come through this. It would say from point A, from point A, 1.607 into 10 raised to power 85 electrons transfer or pass per second. Calculate the total charge that passes through point A. All right.
Yes.
So it's very simple. I am looking. So what is given to me? The total electrons,
Yeah.
right? So this is n basically, and I have
Yeah.
to remember that what is the charge of one electron? Charge of one electron is minus 1.602 into 10 raised to power minus 19 coulomb.
Yes.
Yes or no?
Yes.
So what is the charge? Q is equals to Ne. I know the n. N is 1.607 into 10 raised to power 85 into the value of one electron is going to be minus 1.602 into 10 raised to power minus 19 coulomb. So Q is going to be what? When you multiply 10 raised to power 85 and 10 raised to power minus 19, what is that going to be? 85 plus of minus 19. Because
Yeah.
when bases are same, powers get added up, isn't it?
Yes.
So it is going to be 10 raised to power,
Six.
how much?
Six.
66?
Yeah.
66, correct. So this 10 raised to power 66 would be there. Into, we would have how much? 1.602 into 1.607. Yes or no?
Yes.
So we would just multiply that and whatever the answer comes out to be. It would be how much? 6 times 12? 36, 3.
2.574.
So you have 4, 1, 4, 6, 1, 1, 13, something like that. How much is that coming out to be? 10.311614 itna coulomb. Do you understand my point? Understood or not?
How
Right?
did you get 0.311?
I might be wrong in the multiplication. If you're doing it with the calculator, maybe that is correct. But did you understand? I just have to multiply these two numbers and get the answer.
Yes.
And the net charge will be negative.
Yeah.
Yes or no? That is the
Yes.
concept. Now, the next question that they could ask you is in a different way. They would say, how much? They would say the charge passing through the charge passing through the conductor is 85 coulomb. How many electrons are passing through the conductor? So we know the formula is Q is equals to Ne.
Yes.
And through a conductor, we are saying that 85 coulombs of charge is passing. So charge is going to be 85.
Yep.
N is going to be how much? We have to calculate. And
Yes.
E is the charge of the electron. So that is going to be 1.602 into 10 raised to power minus 19 coulomb. So can you
Yeah.
just calculate this and get the answer 85 over, you divide this, you get 1.602 into 10 raised to power minus 19, these many electrons.
Yes. So it'll be 5.305.
So when you divide 85 with 1.602, you get 5.305
Right.
into 10 raised to power plus 19 electrons would be present in n electrons.
Into 10 raised to power 20.
Okay. Okay.
Yeah.
Right?
Yes.
So a easier method for this would be every time you can't keep dividing, right? So one question we have. So let's suppose if I say question says calculate how many electrons would be there in 1 coulomb of charge. How many electrons would be there in 1 coulomb of charge? So what exactly does that mean? Tell me. So you will say 1.602 into 10 raised to power. So simply basically how you can do this? You are saying Q is equals to Ne.
Yeah.
Q is 1 coulombs of charge. N you have to calculate. And E is the charge of one electron, which is 1.602 into 10 raised to minus 19 coulomb. Basically, this question comes in this form. It says, what is bigger? The question can say, what is bigger? 1 coulomb or the charge of one electron? 1 coulomb charge is bigger or the charge of one electron? Okay.
Mm-hmm.
So the charge of one electron is 1.602 into 10 raised to power minus 19. This is bigger. Yes
Yes.
or
No,
no?
wait. No.
This is smaller.
Smaller. Yeah.
And 1 coulomb is bigger.
Bigger. Yeah.
So then the point is that you know how many electrons, because then some number of electrons should add up to make 1 coulomb.
Yeah.
So 1 coulomb divided by 1.602 into 10 raised to power minus 19 would be N, isn't it?
Yeah.
So 10 raised to power minus 19 goes up here. It becomes 1 into 10 raised to power plus 19 divided
Yeah.
by 1.602, and that is going to give you N. Do you
Yeah.
understand the point?
Yes.
So 1 divided by 1.602, you can't divide that very simply, right? So what do I do is just understand. Can I write 10 raised to power 19 as 10 raised to power 18 times 10 times 1?
Yeah.
And what is this? 10 over 1.602,
Yeah.
isn't it?
Yes.
So 10 divided by 1.602, what exactly do you think would that mean? 10 divided by 1.602 into 10 raised to power 18. So we know that 16 times 6 is 96.
Yes.
That means what do you think you should do? If you divide this, you get 9.625. So you have 9.625 into 10 raised to power 18 electrons shall make N. Understood or not?
Yeah.
Are you sure?
Yes.
So
Wait.
that is
It's not 9.625, right?
how much is it coming out to be?
6.242.
242.
Yeah.
So 9.25 then, approximately.
Yeah.
So these many electrons would basically mean 1 coulomb. So now if I ask you how many electrons are there in 5 coulomb, now it's easier, right? You will say
Yeah.
that 1 coulomb has 9.25 into 10 raised to power 18 electrons. So 5 coulomb shall have 5 into 9.25 into 10 raised to power 18 electrons. Isn't it?
Yeah.
Are you understanding my point?
Yeah.
So that is a concept. If it
Okay.
says that you know how many electrons, just the way I asked you how many electrons are there in 85 coulomb. So if you just remember that you know 1 coulomb consists of 9.25 into 10 raised to power 18 coulomb, 18 electrons. So you very well know that 85 coulombs shall have 85 into 9.25 into 10 raised to power 18 electrons. Are you understanding?
Yeah.
Any doubts on this?
I don't think it's 9.25. I think it's 6.25.
Okay, okay. Yeah, 6.25. What did I write in the previous slide? 16.6 is, oh, sorry. Yeah, it should be 6.25. Correct.
Yeah,
Because
that's right.
16.6 is 96. Correct. Right. Yeah. Okay. So
Yeah.
that's the basic formula that you need to remember. That how many electrons are present in 1 coulomb of charge. And then thereby you can always find out in how many electrons are there in 85 coulomb. Just multiply that number of coulombs with the number of electrons.
Yeah.
Understood or not?
Yes.
So this is one concept. Second concept is about the current. What is current? Just see. What is current? Now understand. When we are talking about current basically means, see, understand. Let's suppose there is person A and there is this person B. All right. Now
Mm.
I am passing 10 coulombs of charge through person A and I am passing 10 coulombs of charge through person B.
Yeah.
Charge through both of them is same.
Yes.
Charge through both of them is same, isn't it?
Yeah.
But what is happening? What is happening? Through body A, through person
Mm-hmm.
A, I am passing this 10 coulombs of charge in 1 second.
Mm-hmm.
And through body B or the person B, I am passing this 10 coulombs of charge in 100 seconds. Who do
Mm-hmm.
you think will have a greater impact of this charge being passed?
A.
A. So basically, it is not the charge which matters. The time in which, that charge is being passed through the person also matters.
Yeah.
So if I am, gradually every day you go to a doctor and you go to some person and the person releases some amount of charge in the body. So that over a month, it might take you several seconds and then you get 10 coulombs of charge, which is nothing for you. You don't even feel the impact.
Yeah.
But the moment you go to some doctor and the person, applies some machine on the body and that immediately gives you 10 coulombs of charge in a second, you will never ever go to that doctor again. Are you understanding?
Yeah.
Because either you will not be left to go again or the impact would be so much that you will never try to go back. My point here is, what is current? Current means how much charge is being passed, charge passed per second
Okay.
is called current. Are you understanding?
Yes.
Charge passed per second is called current. I hope you are understanding the concept. All
Yes.
right. So when I'm talking about the current, okay, when I'm
Mm-hmm.
talking about the current,
Mm-hmm.
so what is the formula of current? If I say, in t seconds, if I say that, in t seconds, q coulombs of charge is passed. If in t seconds, q coulombs of charge is passed. So thereby, in 1 second, q by t coulombs shall be passed.
Yes.
And in 1 second, whatever amount of charge is being passed, that is called current. So current you denoted with I, and I is equals to Q over T. Are you understanding the point?
Yes.
Any doubts in this?
No.
Right? So that is a concept. So for example, when I say I is equals to Q over T, that is a formula of current. And we also know that, if I equals to Q over T, and for that matter, I know Q is equals to NE. So it would be NE over T. Yes or no?
Yes.
Any doubts in this?
No.
Right? What is the point? The point here is that when I say Qi equals to Ne over T, Sometimes, what exactly happens is, just see this part.
Mm-hmm.
They could ask you different types of questions on that. I'll discuss every possible type of question.
Mm-hmm.
So this is one concept, right? Sometimes, they talk about the charge moving in a circular path. They talk about the charge moving in a circular path of given radius. And then they ask you the amount of current. So what is that category? Just have a look. Let's suppose we have some electron or some charge q, okay?
Mm-hmm.
And that charge is moving in the circular path of radius r.
Mm-hmm.
Do you understand my point?
Yes.
OA. OA. Now, what is happening? Just see. What is the path? What is the distance that this charge is moving? 2 pi r.
Yeah.
That shall be the distance, isn't it?
Yes.
And let's suppose the charged particle
Mm-hmm.
is moving with the speed v. The charged particle is moving with the speed v.
Mm-hmm.
Okay. What is the point? The point is the distance is 2 pi r, right?
Mm-hmm.
Because the charge starts from point A, comes back at point A, so distance is 2 pi r. How, what do we know? Do we know that speed into time is distance?
Distance, yeah.
So what is the time taken by this charged particle to go around the full circle? Tell me. To go
Distance of
around the full circle. It will be distance upon speed.
speed, yeah.
Yes or no?
Yes.
So here the time would be distance is 2 pi r and the speed is v.
Yeah.
Yes or no? The speed is v.
Yes.
Sorry. 2 pi r and the speed is v. This is the time.
Yes.
And
Correct.
so this is the time, right? And what charge is moving? Q. So what
Yeah.
is current? Current is Q over T.
Yeah.
So Q is Q. But time is, or I would write it down like this, divided by time, which is Q divided by 2 pi r over V, which is Q into V over 2 pi r. Are you understanding? So I
Yeah.
here would be what? Q V over
2 pi r.
2 pi r. Are you understanding my point?
Yeah.
So that is the concept. So this is also another formula of current. Sometimes depending upon the data that they are giving you, depending upon that also you can calculate the current. So how many formulas of current? Q by T, Ne by T, Q V by 2 pi r, where V is the velocity, R is the radius. Alright. How many formulas of current? Three formulas of current.
Yep.
And current shall also be written down as dq by dt. dq by dt. Understood or not?
Yes.
I hope you know a little bit of differentiation, Pratiksha.
Yes, I do.
You know that? Okay.
Yeah.
So that is the concept. So what exactly do you understand from this particular part? Just have a look. So I equals to q over t equals to ne by t equals to qv by 2 pi r, and that is equals to dq by dt. Are you understanding?
Yeah.
Now, what exactly kind of questions do you get from here? So question number one. And okay, understand one more thing. So I is q over t. Q is charge over seconds. That means
Yes.
coulombs over second. So what is the unit of current?
Amperes.
The unit of current would be coulombs per second, which is also called as amperes. So when you say 1 ampere, that would be 1 coulomb per 1 second. If you say
Yeah.
5 ampere, so ampere is coulombs per second. So you would write it down as 5 coulombs per second. If you say 6 amperes, that you would write it down as 6 coulombs per second.
Yes.
If you do 8 amperes, so that you would write it down as 8 coulombs
8 amperes.
per second,
8 coulombs per second. Yeah.
right? So generally
Yes.
they ask you to define 1 ampere. Generally they ask you to define 1 ampere. Yes or no?
Yeah.
All right, that's important. That's the
Okay.
concept. Do you understand my point?
Yes.
Right. Now, what exactly is happening here? So 1 ampere is going to be 1 coulombs per second. 5 amperes would be 5 coulombs per second, and so on. So this question says an electron moves around an orbit of radius 3.1 to 10 raised to power minus 10 meters in the hydrogen atom. Calculate the current through the orbit of the atom. So you have to find out I,
Yeah.
and who is moving in the circular path?
Electron.
The electron of radius is given to you, which is 3.1 into 10 raised to power 10 meters. Yes or no?
Yeah.
So what do you think I would be? I would be QV
Should be over 2 pi r.
2 pi r. So I here would be Q. Q would be 1.602 into 10 raised to power minus 19 coulomb, because the charge of one electron is 1.602 into 10 raised to power minus 19 coulomb. And this
Yes.
is also, you can say, this is also the smallest charge. Okay, this is also the smallest charge. Understood?
Okay.
What would be the velocity? The velocity is given to you. Okay, the velocity is not given to you in the question. So let's take the velocity of the electron B is moving with the velocity 2.15 into 10 raised to power 3 meters per second. Okay, so 2,
Okay.
yeah. So I into V, sorry, Q into V is 2.1 into 10 raised to power 3. Everything has to be in the SI unit. I hope you're understanding.
Yeah.
So it is going to be 2.1 into 10 raised to power 3. 2 pi is 3.14, and R would be how much? R would be how much? R
Uh,
is given to me as how much? Just let me check.
uh,
It is given to me 3.1 into 10 raised to power minus 10.
yeah.
3.1 into 10 raised to power minus 10 meters. So first you check that this is in the SI unit. I hope you're understanding.
Yeah.
So I comes out to be what? I is going to be 10 raised to power minus 10, 10 raised to power minus 19, 10 raised to power 3. So this is basically 1.602 into 2.1. The numbers I'm accumulating on one side. And 10 raised to power 3 minus 19 plus 10. I hope you're understanding. This minus 10 goes up.
Yep. Plus.
So yeah, so that becomes 10 raised to power minus 16
Yeah.
minus 6
8,
into
9,
1.602 into 2.1.
12, right?
Right, well, it is becoming 13.
Oh,
13
13.
minus 9,
Yeah.
right?
Yes. Yes.
And it is 2 into 3.14 into 3.1. So approximately 2.1 and 2 cancels out.
Yeah.
So approximately 3.1 into 3.1, this is going to be approximately 10, 9 point something, right?
Yeah.
So you have this part. Yes or no? So
Yeah.
1.602 over 3.14 into 3.1 into 10 raised to the minus 6 is going to be I. Yes or no?
Yes.
So this is going to be I. That much, whatever it is, this much amperes would be the current.
Got it.
Got it?
Yes.
There could be another possibility of question. They would say through a conductor. Through a conductor,
Mm-hmm.
5 amperes of charge flows through a point. Through a conductor, 5 amperes of charge flows through a point. Okay?
Mm-hmm.
It says
Yeah.
calculate the number of electrons passing through the point in 3 seconds. Okay?
Yeah.
So, what is the formula? We know that I equals to Q by T,
Yes.
and Q is basically NE by T.
Yes.
So, current is given to me as 5. The question asks me to calculate the number of electrons. So, N is to be calculated. E is what? 1.602 into 10 raised to the power minus 19.
Yep.
And
And T is
time is 3 seconds. So just
yeah.
solve it to get N. So you get 5 into 3 divided by
1 point.
1.602 into 10 raised to the power minus 19.
Yes.
Simple. Any doubts
Yep.
on this?
No.
All right. This is the. Any doubts in this?
No.
Sure.
Yes.
All right. So on the similar lines, we have another part of it. It says what? Just see. It says calculate the current through a point such that calculate the current through the point such that 1.9 into 10 raised to the power 80 electrons pass through it in 10 minutes. Okay.
Yep.
The very basic question. It wants you to calculate the current through a
Yes.
particular point. So through a particular point, you understand that when the electrons are crossing this particular part,
Mm-hmm.
when the electrons are crossing this particular part, what exactly is happening? Just tell me. When the electrons are actually crossing this particular electron, what exactly does it mean? Just tell me. So we have this particular electron.
Mm-hmm.
Yes or no?
Yeah.
And when these electrons are actually crossing the particular part, just have a look. This is it.
Yes.
So what is the total charge that is passing through these electrons? Just tell me. It would be 1.9 into 10 raised to the power 80 into 1.602 into 10 raised to the power minus 19. This much is the total charge over time. But
Yeah.
time has to be in seconds. Are you understanding? Time has to be in seconds. So it would be
Yes.
10 into 60. So that would be the current.
Yep. Got
Understood
it.
or not?
Yes.
Simple. And just
Yep.
make the calculations because 1 minute is 60 seconds. So 18 minutes, 10 minutes would be how much? 60, 100. So this is going to be 600,
Yes.
right?
Yep.
And whatever the answer, you can solve it and you get the current.
Yeah.
So I think the concept of current is clear. So these are different possible types of question that you could get. But
Mm-hmm.
understand one thing, that this is a kind of question. This is going to be the toughest question that could be framed on the current.
Okay.
Okay. So because normally people, teachers don't discuss that either, and also, uh, you know, kids don't get it in single go what exactly is happening. So please try out this question. Rest the
Yeah.
normal questions are same. They would give you charge, ask you current. They will give you charge and time, ask you current. Give you current and time, ask you charge, and number of questions like that.
Yeah.
One possible question that could be framed here would be this. They could say that, the question could say this way: calculate. Are you aware little bit about differentiation and integration, Pratiksha?
Yes.
Good job. So question would say something like this. Question says the amount of charge passing through a device, passing through a point with respect to time, is given as per the following formula. Okay.
Yeah.
What is that? Number one, the amount of charge passing through a point with respect to given as per the following formula. Q equals to 6t square plus 18t minus 9 minus 19. Question says calculate the current at t equals to 3 seconds. Calculate the current at t equals to 3 seconds. What does that mean?
You can differentiate it.
You can differentiate it because I know that current is equals to dq by dt.
Yep.
So you differentiate it. What do you get? You get 12t
Yeah.
plus
Plus 18.
18t, and
Yep.
that's my current. And what kind of current is that? It is going to be an instantaneous. It is going to be an instantaneous current. I hope you're understanding.
Yeah.
So what exactly does that mean? You tell me. It is going to be 12 times 3 because at 3 seconds I'm supposed to calculate plus 18.
Yeah.
Oh, I'm so sorry. That is just 18 plus
Yeah.
18.
18.
So 36 plus 18, and that is going to be 54 amperes of current.
Yeah.
Okay.
Yes.
So this is one concept that they could give you. I'm just discussing every possible kind of question that could be framed out of it. I hope you're understanding.
Yes.
On the similar lines, they could ask you this. On the similar lines, they could ask you this. They could say, calculate the charge flowing calculate the charge flowing through a conductor. Calculate the charge flowing through a conductor such that such that the current through the conductor from t equals to 0 to t equals to 7 seconds, where current is given to you as what? One second.
Yeah.
Right? So it says calculate the charge flowing through the conductor from t equals to 0 to t equals to 7 seconds, where I is equals to t cube plus 9t. T, the question is something like this: t over 2, t plus 9, something like that.
Mm-hmm.
So, how would you calculate the charge?
Integration.
Integration. So, what do we know? We know that I is nothing but dq by dt.
Yes.
And dq by dt would be what? Dq by dt would be I. And that is given to me as t plus 9.
Yeah.
So, dq shall be what? T plus 9 times dt.
Yeah.
And integrating both sides. So here, what do you think we have? Here we have q raised to power 0. So it is going to be q raised to power 0 plus 1 over 0 plus 1,
Yeah.
isn't it? And that is going to be t square by 2 plus 9t over the limit 0 to 7. Yes or no?
Yes.
And just we are going to put in what? The higher limits, upper limits,
Upper limit.
minus
Yeah.
the lower limits. So we're going to get 7 square by 2 plus 9 times 7
Yeah.
minus 0 square by 2 plus 9 times 0. So
Yes.
q here is going to be what? 49 over 2 plus 63.
Yeah.
So q here is going to be how much? 49 over 2 plus 63. So 49 over 2 plus 63. And that would be 2 times 1. Okay, 2 times 1 and 2 times 4.5. So it is going to be 24.5 plus 63. So that is going to be 87.5 coulombs would be the net charge.
Yes.
Right?
Yeah.
So this is one concept.
Yeah.
Understood or not?
Yes.
Right? Sometimes, they could also give you this kind of scenario. They would give you this, that it is not a linear current. They would say the current is moving like this. Something like that.
Mm-hmm.
And it says this is, right, something like that.
Yeah.
And the question says calculate, and this is how much? This is 10 amperes,
Mm-hmm.
and this is 15 amperes.
Mm-hmm.
And the question says calculate the charge flown through the device in 10 seconds. Okay?
Yeah.
So, what do you understand from this graph? Just see. Always understand that, we have a y axis and we have an x axis.
Yeah.
So, when we have a y axis and when we have a x axis, what is going to happen? Tell me. When we have a y axis and when we have an x axis, what exactly happens? Always understand two things you can do. Either you can do y over x or you can do y into x. Isn't it?
Mm-hmm.
If you do y over x and if you do y into x,
Mm-hmm.
that means y, the term expressed on y into term expressed on x.
Yeah.
And the term expressed on y divided by the term expressed on x. You can either divide or you can multiply. You understand?
Yes.
So when you're multiplying the terms, it should make a physical quantity. Either you're multiplying the term should make a physical quantity, or if you're dividing the term, that should also make a physical quantity.
Yeah.
So here, do you tell me along y we have current, along x
Yes.
we have time? Yes or no?
Yeah.
So
So you should
I
multiply
into t makes an important thing, or I over t makes an important thing?
I into T.
I into t. And whenever you are finding that y into x makes an important term for me, then from the graph you have to calculate the area. And if you have to find an important quantity y over x, doing y over x, then you are supposed to find the slope. Are you understanding?
Yes.
So this is the concept. So when I am understanding, when I am talking about y over x and y into x,
Mm-hmm.
right? Always
Yeah.
understand what is the question asking you. The question is asking you the charge. And charge I can calculate by doing I into t. Are you understanding my point?
Yeah.
So charge is basically I into t. I hope you're understanding. And what is I?
Yeah.
I is a physical quantity expressed along y-axis.
Y-axis. Yes.
And t, that is time, is a physical quantity expressed along x-axis.
Yep.
And I have to multiply these two to get charge. That means I have to multiply the term expressed on y-axis into the term expressed on x-axis. And then I will get my charge. That means what? But that is basically, that is just giving me an idea that, y into x is going to give me my required term. But when the
Yeah.
graph is given to me, I have to, once I figure it out that, it has to be y into x,
We have to
then
find
what?
area.
Then find the area. Simple. And when you
Okay.
just find the area, what exactly do you think you will get? Tell me. What exactly do you think you will get? So just calculate the area. So what is the method to calculate the area? Let me mark the areas as O, A, B, C, D.
Mm-hmm.
So this, the blue area, the blue triangle, that is going to be a right angle triangle.
Half
So
into 2 into 10.
exactly. So the area, if I mark it X and Y and Z and D, so
Mm-hmm.
area triangle OXA. So that is half into base is 2
Yeah.
and height is 10.
Yes.
So this much area is coming out to be 10 centimeter square.
Yeah.
Then area of quadrilateral ABYX, what would that be? Length would be 3
Yeah.
and breadth would be 10. So that would be 30 centimeter square.
Yeah.
Then area would be the area of the trapezium.
Half into 2 into 10 plus 15.
Correct. So half into 10 plus 15 into the height. Height is 2.
Yeah.
So that is going to be 25.
Yes.
So 10 plus 30, 40 and 65. And then what do you think we have? The area of the the red area. That is going to
Half
be
into
half into
3
3
into
into height is 15. So that
15.
is 45 over 2 and that should be 22.5. Yes or no?
Yes.
So this area would be 22.5 centimeter square. So this entire area would actually give me the required charge. And what is that going to be? 10 plus 30 plus 25 plus 22.5.
Yeah.
So it would be 7 and 4 and 3, 7 and 8, 87.5. Do you understand? That would be 87.5. Understood or not?
Yes.
Any doubts in this?
No.
Alright? That is it.
Yes. Got it.
So current is actually a very, very vast topic. There could be questions depending upon, depending upon the graph, depending upon current, I equals to, right? There could be
Yeah.
multiple kinds of questions,
Yes.
right? I hope it is all good.
Yeah.
Alright? Now, just so this is about the current. Okay. Now, what do we have in here? Just see. Next topic that we're going to do is the relation between current and drift velocity. Relation between current and drift velocity.
Yeah.
You remember that yesterday I told you that whenever electrons move from one end to the another
Mm-hmm.
in a conductor,
Yeah.
so we have to connect that conductor through the this is negative end
Positive terminals. Yeah.
and this was the positive end,
Yes.
and there was these free electrons in the center.
Yeah.
So when we have these free electrons exactly in the center, what do you think would basically do? These electrons would randomly move
Yes.
so as to cancel out each other's motion. But because of the negative terminal, these electrons would start moving in a specific direction. Are you understanding?
Yes.
And when these electrons would start moving in a specific direction, it would move from the negative end to the positive end. It would move from the negative end to the positive end. Are you understanding?
Yeah.
That basically means what? That basically means what? That they are moving in a straight line from end A to end B with a certain velocity, and that velocity is called
Drift velocity.
as the drift velocity. You understand the point?
Yes.
One second. कौन है? ये क्या ले आया? ये क्या है? कॉल इन. लेकिन दरवाजा बंद कर दो. हाँ. प्रतीक्षा. बंद है. हर तरह से. दफा हो जाना चल. अरे तो मैंने बंद कर रखा ना, तो जाओ उधर दफा हो जाओ. तो यहाँ पे खड़े होके करने सारे काम. Right. So basically, when we are talking about the relation between the current and the drift velocity, now just now there is a very very important before deriving that you have to understand a very important term, and that is called electric field. What is electric field? Just understand. I hope you're there, Pratisha.
Yes, I am.
Yes. Now it says that when we're talking about the electric field, right? Understand. Let's suppose there's this charged particle Q. Okay.
Yeah.
There is a charged particle Q. When we have this charged particle, when we have this charged particle, so what is happening? This charged particle will have its own influence. What kind of influence? That if for example there is a small charge Q, red charge. So because this red charge is in the area of this big charge, okay,
Mm-hmm.
so this big positive charge shall repel this small Q charge.
Yes.
And thereby this small Q charge might experience a force backward.
Yep.
Might experience a force
Backwards.
backwards.
Yes.
Are you understanding?
Yes.
So, but if I place this charge at, let's suppose, point B plus Q charge, it might again experience a force backward. Yes or no?
Yes.
If I place the charge plus Q at point C, it might remain there. That means what? That means, ma'am, the influence of capital Q charge is actually reaching only B point, up till B point. And let's suppose that B point is at a distance of, let's suppose, 15 meters or 15 centimeters. So in all the directions around the charge, around the source charge capital Q, all around the source charge capital Q, do you understand we have up till 15 centimeters in all the directions?
Yes.
You understand? The
Yes.
influence of this capital source charge shall be there. Are you understanding?
Yes.
What is the point? The point is, that when we are talking about the electric field, okay? So what
Mm-hmm.
is electric field? Electric field, first of all, in the general terms, if you understand. So
Mm-hmm.
electric field means the area around the source charge. The area around the source charge. Yes or no?
Yes.
But mathematically, what is electric field? Mathematically, what is electric field? So we have to understand that, right? So first thing, the area around the source charge where its influence could be felt is called electric field. Mathematically, this is the meaning.
Yeah.
Right? Where the influence of source charge बेटा दूसरे रूम से आओ निखिल दूसरे रूम का दरवाजा खोल दे where the influence of source charge could be felt. Yes or no?
Yes.
So this is the concept. So when I talk about this particular part, just understand that the electric field that we're talking about. How does it exactly work? Just see. So we have a capital Q charge. This is the area. Yes or no?
Yeah.
This is the area.
Mm-hmm.
And we have here a small Q charge, which say, let's suppose is a 2 coulomb charge at point A.
Yeah.
And this is, let's suppose, some charge which is, let's suppose, 1000 coulomb. Understood?
Yes.
Now, 1000 coulomb, because it is a source charge, it is a big charge. So its magnitude is very high. And that is why the force applied by the source charge would be very, very high.
Yeah.
So what is happening? So we have this, we have the small A charge. And just see now. So this capital Q shall push it. That capital Q might push it with some force. Let's suppose it is pushing it with 100 Newton force at a distance of, let's suppose, 10 centimeters.
Yeah.
If let's suppose this point is at, let's suppose, A point, rather than being at point A, it is at, let's suppose, point B. And it is
Mm-hmm.
again the same 2 coulomb charge, but now this 2 coulomb charge is experiencing a backward force of, let's suppose, 500 newtons because it has come closer to the source charge, isn't it?
Yes.
So point B is closer to the source charge, and
Yeah.
point A is away
Further.
from the source charge. Are you understanding?
Yes.
So I am saying that the same 2 coulombs of test charge, is experiencing a 500 newtons of force, and the same
Yeah.
2 coulombs of test charge is experiencing 100 newtons of force. So you
Yes.
understand one thing. The point here is that we do not know what could be the test charge. Test charge could be any small charge, isn't it?
Yeah.
It could be 3 coulomb, it could be 4 coulomb. Who decided the value of 2 coulomb? Nobody. It was my wish that, no, I'm going to bring 2 coulombs of test charge inside. You
Yeah.
understand? What is
Yeah.
the point? The point is that when we have this 2 coulombs of test charge and when we have this 2 coulombs of test charge B, Same charges placed at the same two different points. You understand that 1000 coulombs of source charge is there,
Yeah.
right? What is happening? So we have this test charge. So I would say that if 2 coulombs of test charge is experiencing 100 newtons of force at point A, so how much would 1 coulombs of test charge would experience? It would experience 100 over 2. That means 50 newtons per coulomb.
Yeah.
Yes or no? It would experience 50 newtons per coulomb.
Yep.
Any doubts on that?
No.
Similarly, if I have, at point B, what would that mean? That, ma'am, at point B, the same 2 coulombs of test charge is experiencing 500 newtons of force. So 1 coulombs of test charge is experiencing 500 over 2. That would be 250 newtons per coulomb.
Yes.
What is happening? That, ma'am, if I know that, at point A, now understand how many points like A could be there around the charge capital Q. What am I saying? How many points like point A could be there around the test charge capital Q? So it was
Mm-hmm.
going to be how much? To tell me. It is going to be all the points in a circle which are all at a distance of 10 centimeters from the test charge, from the source charge capital Q. Yes or no?
Yes.
I hope you're understanding the point,
Yeah.
right? What am I trying to tell you? What am I trying to tell you? That all the points like B, they're all the points in the circle which are a little closer. And let's suppose the distance, if the distance of point B is, let's suppose, 6 centimeters. You understand? So if this is 6 centimeters, all these points around the point would all be at 6 centimeters, isn't it?
Yes.
What exactly does that mean? You tell me. What exactly does that mean? That, ma'am, all the points would behave exactly in the same way, just the point B is behaving because they're all at the same distance in the circular path.
Away from source charge.
Source charge
Yes.
capital Q. So all the points, if I place 1 coulomb test charge, all of them are going to experience a force of 250 newtons. 250 newtons if I place 1 coulomb here, 250 newton here. If I place 1 newton here, I experience 250 newton again.
Yes.
So force experience per coulomb. Now I know the characteristic of every point on this particular line. Are you understanding?
Yeah.
Every point behaves in a similar manner. Every point says that, I will have 250 newtons per coulomb if you place a 1 coulomb of test charge and around this particular source charge, capital Q, which is 1000 coulomb. Any point, any charge placed at 1 coulomb would do what? Would do what? Tell me. Would experience
Of
a 250 newtons of test charge.
course. Yeah.
You understand?
Yes.
The point is here what? The point is, that 1 coulombs of test charge, I know the value, I know the force experienced by 1 coulombs of test charge. Now what do? I say, no, I don't want to bring 1 coulomb, nor I want to bring 2 coulomb. I want to bring 7 coulombs. I want to bring a bigger test charge because test charge definitely smaller than the source charge. So smaller, like not 999 coulomb, not that much. That is very comparable. Smaller as
Yeah.
little, extremely smaller. It should be smaller.
Yeah.
What exactly does that mean? So when we have 7 coulombs of test charge here, 7 coulombs of test charge, you know that if I would have placed 1 coulombs of test charge here, and then I would have experienced 250 newtons of force. Now the test charge is increased. So don't you think the interaction between the two charges would increase? The
Yes.
repulsion between the two charges would increase, and thereby
Yeah.
this 7 coulombs would experience how much charge? This 7 coulombs would thereby experience 7 times 250. Yes or no?
Yes.
So you would have how much? 7 into 250. What would that be? That would be 1400 plus 7 times 50 would be 350, and that would be 1750 newtons of force this 7 coulombs of test charge would experience. Are you understanding my point?
Yes.
What do you understand from this point? Tell me. The point here would be, the point here would be what? The point is that if we have this 1 coulombs of test charge, right? Any doubts on this, right?
No, no, got it. Yeah.
So can I just say that force? So if I say if I place a q, small q coulombs of test charge, and because of the source charge, if that test charge experiences capital F force,
Mm-hmm.
so 1 coulombs of test charge will experience how much force is F by Q.
Yes.
And if I know that particular point with regards to F by Q, if I know that value, I also know that, if I place any other test charge at that particular point, how much force would that small test charge experience in the presence of that source charge? Are you understanding?
Yes.
Are you understanding my point? So this is the
Yeah.
concept. This is the concept. So you understand that, Q test charge experiences F newtons of force, F newtons of force. You understand? So
Mm-hmm.
the formula of electric field is F over Q.
Q.
So what is Q here? This Q is the test charge. Do you
Yes.
understand my point?
Yep.
Right? So we are defining every point. So now you tell me, so if we have this capital Q charge and there are different, circles here, what are these circles representing? These circles are representing different, these circles are representing what?
Electric field.
Different points, all the similar points, So if I say point A and point B and point C, don't you think we are moving away from the source charge?
Yeah.
Right? And if we are moving away from the source charge, what is happening? You tell me. If we are moving away from the source charge, what is happening? When we are moving away from the source charge, tell me, what does that mean?
There's less and less force.
Less and less electric field.
Yeah.
Less is the electric field.
Field.
You understand my point?
Yep.
And who experiences the force? So if I say like this, so force over test charge qt is going to be electric field. So if I have to know, if I know an electric field at a particular point, can I say test charge times electric field would give me the amount of force that test charge is experiencing? Qt
Yes.
times electric field. So if I know, if I know the value here, if I say the electric field here is 250 newtons per coulomb or 1250 newtons per coulomb, or I would say 50 newtons per coulomb since you're very far off.
Mm-hmm.
Oh, 1 second, Pratiksha. I need to connect it to a charger. 1 second.
Yeah.
Don't take lunch. So what exactly does that mean? Just see. So I would say that test charge times electric field would give me what? Test charge times electric field would give me what? The amount of
Four.
force experienced. Yes or no?
Yeah. Yes.
That is the concept. Understood or not?
Yes.
Okay. Now you just see what is happening. When we have this concept of force equals to qt times electric field, right? This part, right?
Mm-hmm.
Now let's take an example here. Now what do we do? Understand one thing. So do you understand that if I take a metallic sheet like this and I connect it to the socket, one metallic sheet, I take it like this, and there is another metallic sheet right here,
Mm-hmm.
like this, and this is carrying a positive charge because I have connected to the positive terminal of the battery,
Mm-hmm.
and this is connected to the negative charge. You understand?
Yes.
Now, because I have connected to the positive charge and because I have connected to the negative charge, what is happening? Tell me. What is happening? Because I've connected to the positive charge and because I've connected to the negative charge, what is happening? That, ma'am, if I place this electron here in the center,
Mm-hmm.
do you realize one thing what is happening? Because this rod is carrying a positive charge, don't you think that it is going to create an electric field around itself on both the sides?
Yes. Yes.
And because this rod B is also carrying a negative charge, don't you think this negative rod would again be carrying the
Yes.
electric field? Will also be
Yes.
creating its own electric field on either its sides.
Yes.
Which area do you think has more amount of electric field? Which area do you think has more amount of electric field? Area A, this area?
Yeah.
Yes or no?
Yeah, because of attraction.
Exactly. And because this electron is negative, don't you think that the negative rod will repel it and the positive rod will attract it?
Yes.
So both the rods sort of, both the rods are sort of doing what? Both the rods are sort of making the electron move in a specific direction. And that is from negative to positive. Are you understanding?
Yes.
That means when the electron is in the battery, and one
Mm.
terminal is negative and one terminal is positive. So the
Yeah.
electron is actually forced to move from the negative terminal. It is pushed from the negative terminal side to move towards the positive terminal side. Are you understanding?
Yes.
Any doubts on this?
No.
Right? This is the concept. So when I say that, the electron is being pushed from one side
Mm-hmm.
to move towards the positive side, all the electrons which you place here. So one thing you understand, who is going to be a bigger charge here? Tell me. Who is going to be a bigger charge here? Tell me.
Mm.
A bigger charge is the charge of the rods because that's a large quantity of charge, isn't it?
Yeah.
That's a large quantity of positive charge here. Sorry. There's a large quantity of positive charge here.
Yes.
Large quantity of positive charge here. And there would be a
Yeah.
large quantity of negative charge here. So these charges are creating an electric field in this area between the two rods, and I would call this electron as my test charge. Yes or no? I would call this electron as my test charge, isn't it?
Yes.
So when I'm calling these electrons as my test charge, what do you think would happen? Tell me. That, ma'am, this test charge, so if for example at this particular point E, at this particular point A, the electric field is E.
Mm-hmm.
So how much force do you think that this electron when placed at this point A would experience? So it would create F over
But
E as the electric field. So don't you think the force here shall be EE? The force experienced by the charge electron here would be QE. Q is what the QT used to be the charge test charge.
Yeah.
So wouldn't that be EE?
Yes.
Any doubts on this?
No.
Sure.
Yes.
This is the concept. This is the concept. So when I'm talking about this particular part, just understand, that both the rods, they create an electric field in the center, and in this electric field in this area, if I leave an electron, that electron will move towards the positive end. Okay.
Mm-hmm.
And that will move towards the positive end because the negative end is pushing it.
Yes.
Simple, right?
Got
And
it.
how much force will that electron experience? That force will be EE, capital E, because E is going to be my test charge here.
Yeah.
And the formula of force is test charge times electric field.
Yes.
Test charge times electric field. Yes or no?
Yes.
Understood or not?
Yes.
Right? Also, one more thing you understand, you must be wondering that, ma'am, if I'm closer to this rod and if I'm closer to the rod A, in both the places, don't you think the electric field here should be more? And as we
No.
move away from it, the electric field should be less. But when I create the two rods, one having a positive charge and one having a negative charge, so this particular area, this particular area is an area of uniform electric field. Okay, it is uniform electric field. Uniform electric field means, and I will be proving it going ahead, but this area electric field means that no matter which point you are at, the value of electric field is exactly the same. Okay, the
Yeah.
value of electric field is the same. Being same means that, if I place a 1 coulomb test charge here, if I place a 1 coulomb test charge at point B, if I
Mm-hmm.
place a 1 coulomb test charge at point D, if I place a 1 coulomb test charge at point F, if I place a 1 coulomb test charge at G, 1 coulomb test charge at E, no matter where I place it, okay,
Mm-hmm.
if the electric field at point A is 50 newtons per coulomb, it would still be the same at every point. That's what uniform electric field means.
Yes.
Are you understanding?
Yeah.
So, how do we denote a uniform electric field? Because the value at every point is exactly the same.
Yep.
So, how do I denote a uniform electric field? Understand? So, the uniform electric field would be like this: parallel lines which are equally spaced. Parallel lines which are equally spaced. Are you understanding my point?
Yeah.
Any doubts on this? So, these are the parallel lines which are equally spaced.
Which direction does it go in? Negative to positive, positive to negative.
It goes from negative to positive.
Okay.
Right here in this example, the electric field lines would be moving like this,
Okay.
right?
Yeah.
See, basically, I'll tell you one thing. Conventionally, the directions are from positive to negative. Honestly saying,
Yeah.
the directions are from positive to negative. But I would say that, the actually, why is that so? I'll tell you why. Because scientists, they assume the test charge as a positive test charge. They did not consider the electron at that time. It is of that time when they never knew that, electrons could move. So they thought that the test charge would be 1 coulomb positive charge.
Yeah.
So if the test charge is considered to be positive test charge, I hope you're understanding that the positive ions would be pushed here and the negative would be pushed on this side. Yes or
Yes.
no?
Yeah.
So when this is happening, what exactly do you think would happen? Then, according to the positive test charge, because the positive would repel positive, the positive rod, A rod, would repel the positive test charge at X point.
Yes.
You understand?
Yeah.
So what is happening? Right? So I am pushing it, isn't it?
Yeah.
So definitely the electric field lines would be considered in the positive to negative direction. But the value would still be the same at every point,
Yeah.
right? So it depends upon the test charge. But honestly saying, they have considered the conventional test charge. They have considered the conventional test charge to be a positive test charge. And according to that, they have fixed the directions of the electric field, which is from positive to negative.
Negative. Yeah.
All right. But that is
Yes.
with regards to the positive test charge. I hope you're understanding.
Yes.
But in reality, how do you define an electric field line? How do we define an electric field line? How do we define an electric field line? An electric field line is a path, along which a unit positive test charge would move. Okay, along which a unit positive means plus 1 coulomb. Unity means 1, right? Along which
Yeah.
a unit positive test charge would move. Are you understanding the point?
Yes.
Any doubts in this?
No.
Right? So that is the concept. So if I want you to draw the electric field lines of, the positive test charge, what do you think would happen? Tell me. Don't you think the electric field lines, if I leave a positive test charge here in the surroundings, the test charge, according to scientists, could never be negative. That's what they said. So
Yeah.
according to them, the test charge would always be positive.
Positive.
But
Yes.
source charge could be anything. Source charge
Yeah.
could be both positive, source charge could be both negative. So if I'm
Yes.
asking you that, where would the electric field lines go? So the electric field lines would sort of, repel it, and this small test charge would move along this particular line. It would go straight.
Yes.
Yes or no? It
Yeah.
would go straight. It would go straight. It would go
Yeah.
straight. Are you understanding my point?
Yes.
Like this. So
Yeah.
I have to do what? I have to draw the outward arrows, because outward arrows means the small test charge is moving away from the source charge. Understood? And if I have a negative source charge, then what would happen? If the test charge is again positive, then the test charge would actually come closer to the source charge. Yes or no?
Yes.
The test charge would come closer to the source charge. So the arrows you have to make. Now, what am I trying to tell you here is just see. Arrows, I'm going to put it closer to the source charge. Yes or no?
Yeah.
Now, what is happening? Understand. Do you see the distance between the field lines? The distance goes on increasing.
Yeah.
The distance between the two field lines goes on increasing. It means what? And we also know that, if we place the 1 coulomb charge here at point A, and if I place the 1 coulomb charge here at point B, where do you think the field is stronger? Where do you think the electric field is stronger? Is more
A.
A. So can I say one thing that, wherever the field lines are closer,
Mm-hmm.
right? The field lines here are closer.
Yes.
So wherever the field lines are closer, okay,
Mm-hmm.
there at those particular places, wherever the field lines are closer, at those particular places, what is happening? The field is stronger. So from the, if for example, if I draw the field lines like this, I say, okay, these are the field lines, right?
Yeah.
And I want you to know that if I mark a point A here and if I mark a point B here, and my question to you is that electric field at point A is greater than electric field at point B, option number 1. Electric field at point B is equals to electric field at point A, option number 2. Electric field at point B is greater than electric field at point A, and option number 4, none of these, or I would say can't be detected. So what do you think you can identify from this? Tell me.
1. A is bigger than B.
Exactly. Why so? Because the electric field lines at point A are reaching towards A, and at A they are more crowded.
Yeah.
And wherever the field lines are more crowded, that means what? That means what? that this value of electric field here, you know, this value of
Mm-hmm.
electric field here at point B would be less.
Yes.
You understand?
Yeah.
Second thing, let's suppose we have a line charge. What do you mean by a line charge? Understand. What do you mean by a line charge? Line charge is basically a sort of, rod, sort of a very thin pen or a pencil, right?
Mm-hmm.
And somehow you are capable of giving some charge to it.
Mm-hmm.
Yes or no?
Yeah.
So here the length is what? Let's suppose the length is L. L
Yeah.
centimeters. And I would say that, on L centimeters of length,
Mm-hmm.
I have given Q coulombs of charge. On L centimeters of length, I have given Q coulombs of charge.
Yes.
What does that mean? Tell me. So thereby, on 1 centimeters of length, how much charge would that be?
Q over
Q over
L.
L. So do you understand my point? So on L centimeters of length, there would be Q coulombs of charge. Thereby, on 1 centimeters of length, there would be Q by L length of charge. So this is called as lambda. Lambda.
Okay.
Lambda will be Q over L. Yes or no?
Yeah.
So this is what? This is lambda. Understood or not?
Yes.
So basically, it means that, if it is a 10 centimeters of charge, length, sorry, and
Mm-hmm.
I have been successful in giving it, let's suppose, 50 coulombs of charge to full length of the rod. So can I just say that, ma'am, on 1 centimeters, you have 5 coulombs of charge? Yes or no?
Yes.
And when you have 5 coulombs of charge, what exactly does that mean? You tell me. If you have 5 coulombs of charge, what exactly would that mean? Tell me. Now, if for any length of wire, if I say that, there is a wire and whose lambda? Lambda, what do you call? You call it as linear charge density. Linear charge density. So its unit would be coulomb upon meter. So coulomb meter inverse shall be the unit of linear charge density. Understood or not?
Yes.
So what do you think would lambda mean? Lambda would be equals to what? Let's suppose if I give you 2.1 into 10 raised to the power minus 3 coulombs centimeter inverse for a particular wire.
Mm-hmm.
And my question to you is what would be the charge? What would be the charge on a 10 centimeters wire? So what would you say? That when okay, some wire would be there? Or let me just mark it as what would be the charge on a 5-meter wire? So what would you say? That okay, this wire is 5 meters long. 5 meters basically means 500 centimeters.
Yeah.
And lambda means what? The linear charge density. That means how much charge we have on 1 centimeters. Yes or no?
Yeah.
So could you not just calculate if you have the charge on 1 centimeters length, you know the charge, which is 2.1 into 10 raised to the power minus 3.
Mm-hmm.
Don't you think you can calculate the charge for 500 centimeters length?
Yes. Into
Some
500.
into 500. Very simple. So if you know the meaning of linear charge density, so directly what you can do, you can simply apply the formula lambda is equals to Q over L. Lambda is going to be 2.1 into 10 raised to the power minus 3 is going to be Q over L. L is going to be 500. And 500 is going to multiply here. So Q would be what? 2.1 into 10 raised to the power minus 3 into 500. Simple. So that much.
Yeah.
So basically, this is coulombs over centimeter into 500 centimeter. So centimeter cancel centimeter. So it is going to be 2 zeros cancel this. So you have 5 and the 5 is 10. 10.5 into 10 raised to the minus 1. And that would be 1.05 coulombs. Yes or no?
Yes.
Any doubts on this?
No.
All right. That is the concept, right?
Yeah.
One second.
Yeah.
All right. So this is how we basically have to work.
Yeah.
Similarly, we have a areal charge density or surface charge density or a surface charge density. Okay.
Mm-hmm.
So when we are talking about the surface charge density, what exactly does surface charge density means? Let's suppose we have this surface, right?
Yeah.
And let's suppose this length is 6 centimeters and this length is, let's suppose, 8 centimeters. So if I
Mm.
have a 1, 2, 3, 4, 5, 6, right? So what I'm trying to do, I'm going to make 6 equal partitions. So I hope you understand that every partition is of 1 centimeters length. And here I make, are you understanding? 1, 2, 3, 4, 5, 6, 7, 8. So here also every partition is of 1 centimeters length. Yes or no?
Yeah.
So what do you understand from this? You will say that, ma'am, if the total charge on these, on this box, on this, flat surface is, let's suppose the total charge that I've given is, let's suppose, um, 192 coulomb. So full charge I've given to this box is 192 coulomb. That means that full charge is actually present on the full box. Yes or no?
Yes.
My question to you is that how much charge would be present in this one small box? And what is the area of this one small box? 1 centimeter square, because length into breadth, which shall be 1 centimeters times 1 centimeter. Are you understanding?
Yes.
Which means what? Which means what? You tell me.
192 over 48.
Correct. So I want to know how much is the charge on this one box. So I would say that 48 centimeter square, because there are 48 such boxes.
Yes.
So 48 such boxes overall will contain 192 coulombs of charge.
Yep.
So 1 centimeter square of the charge would have 192 over 48, isn't it?
Yeah.
So that would be how much? 2 times 24 and 2 times 9, 6, 24 times 4. So 1 centimeter square shall have 4 coulombs of charge. Yes or no?
Yes.
Basically, that means that, if you have 1 centimeter square as this much, so charge over area is called as sigma. Okay, sigma is called as surface charge density. Are you understanding my point?
Yeah.
Did you understand the point?
Yes, ma'am.
Hmm?
Yes.
So what is the unit for sigma? That is surface charge density. That is coulomb over meter square. So coulomb meter square shall be the surface charge density. Understood or not?
Yes.
Okay, that is the concept.
Yeah.
So whenever we are talking about the surface charge density, that is coulomb per meter square, I hope you're understanding that surface charge density would be the amount of charge present in 1 centimeter square area.
Yeah.
Any doubts in this?
No.
Right? So this is how we would proceed further. So today this would be the last topic, right? Tomorrow, if
Okay.
we can schedule a class,
Yes.
Can we do that?
Tomorrow also. Yeah, I have holiday tomorrow also.
Correct.